Thank you, Maury. Hope everybody can see the screen properly. I have the title
Yep,
screen on right now.
It's looking good.
Excellent. So I was gonna do a little bit of a competitive YouTube with Scott here, but yes, do visit our HMI SCADA channel. We have a lot of great content here being posted. I have some additional information there. I'll touch upon that in a little while. Before I get into the 2020 R2 What's New, which is really the focus of the presentation, I do want to highlight, especially for those of you that perhaps are not acquainted with what we do on a day-to-day basis, we divide our communication drivers into several tiers. And basically, here's what I say. We speak PLC, so we have a great array of protocols to communicate with the different PLCs. But we also now have a very strong focus in IoT, because even if you are focused on plant floor communications, the Internet of Things connectivity, and as Scott mentioned, the industrial Internet of Things connectivity is becoming very broad. You now can pull the data from your typical assets and take it to other parts of your enterprise, and we'll speak about that in a little while. And also, think about pulling data from areas that are not typical to our connectivity. Web services, that's what we call web services. So treating a web service as a connectivity to the PLC and then pumping that data into our application clients such as InTouch System Platform, Historian, and whatnot. And last but not least, if you were here last year, we also introduced a new offering for our telemetry type products, which is what we call the Aveva Telemetry Server, which we focus more on things like power distribution, water, wastewater, oil and gas in the areas of distributed applications, leveraging protocols such as DMP3, IEC 60870, and also Modbus RTU. So keep that in mind through our presentation. Other parts that I think are important to our strategy is to understand the breadth of how you can leverage the connectivity portfolio with your applications. Starting with, I show here the example of traditional connectivity, where we have the devices at the bottom going through our communication driver, going into our applications. So this is what we call the traditional communication. But then we start leveraging more and more how do we deal with PLC redundancy? So our communication drivers have built-in network path connectivity, so that if your PLC supports 2 network cards, we can automatically switch over in those cases. Or now we start bringing the data into system platform, where you start now consolidating different assets into a larger application, and system platform is great on being that data concentrator, that platform there for you. And moving more into a more higher communication bandwidth, now system platform itself can then start communicating with different drivers here at the bottom, where we have the communication redundancy. And then we continue to bring that high availability through application server by leveraging the application server redundancy itself, the redundant engines in application server. And also with now the professional edition of the communication driver, you can start segregating each driver into its own independent instance for higher scalability and robustness, which brings even more robustness, scalability, and performance to your application. And last but not least, obviously, what we have been doing more and more is to now consolidate the connectivity and then bring it into a set of redundant pairs, where you get not only a scalability, but also a tremendous amount of high availability. So a lot of options there for you guys based on your needs. Now let's transition over to 2020 R2. And first and foremost, I'm gonna talk a little bit about installation. This is really not a big feature, but for some of you, it'll be very beneficial as we move along into our releases. It's gonna be simpler for you to install your communication drivers. Instead of downloading them from the website, we now are including them as part of the communication driver, as part of the system platform installer, making it simpler for you to do that. John also mentioned that as we are going to start doing what we call Patch Tuesdays, it's more important for you to have a consolidated suite. So we keep those driver updates more consolidated for you. Now, what you're going to see here, then it's easier for you to add that information into your applications because the drivers are literally within your installation media. And one small thing, this is not major, but keep in mind that as you transition from the legacy connectivity of what you had before your OI servers or DA servers, now you're going to see a consolidated entry in the communication in the control panel I remove programs, which is called Communication Driver Pack 2020 R2 and so on. So just keep that in mind. That'll facilitate a little bit of what you're doing with your applications. One more note, although included in system platform, the communication driver pack is also available as a standalone installer, because sometimes you guys use the latest communication drivers with previous version or system platform. So you can actually do that as well. You can install the latest communication drivers pack downloadable from the global customer support site in previous versions of system platform. But I'll move forward to our next what's new in 2020 R2. Eduardo did mention with the InTouch application that we have added OPC UA as part of 2020 R2. And it is important to note that OPC UA continues to become a very important industrial standard as in industrial applications. And it's not only to connect to PLC devices as this is traditional task. Some of the other applications, some of ERP systems and some of other business applications are starting to support OPC UA. Even in some cases, Amazon Web Services are starting to support OPC UA connectivity. So do pay attention to that. We're adding it here to the platform, as you can see, instead of independent, so that the products themselves in 2020 application server system platform became an OPC UA server. Now in 2020 R2, we have added InTouch to also be an OPC UA server. Although Aveva Edge is an OPC UA server, they're still working on becoming part of the platform common services. So we'll add them to this diagram in a little bit in the future. But it is important to know the transition from OPC to OPC UA, mostly for the purpose of security. You know, security is becoming pivotal in what we do in our integration. So keep in mind that as we connect into OPC UA server, the connectivity between the server and the client is typically due to security purposes. So just to show you the two examples of how do you bring about configuring application server, it's through the orchestra services, and very simply, we have a pre-built template there for you. So you just enable some components here to enable application server system platform to become an OPC UA server. Again, this is the opposite of what you have through our typical OI gateway OPC UA client. Now you're exposing the application server data to a third-party OPC UA client. And in system platform, if you have multiple nodes, then you can enable different types of configuration to the client. In InTouch, as Eduardo showed, it's actually very simple to enable the OPC UA server connectivity. There in the InTouch application manager, you have the item to enable it. And then similar to what you see in application server, you have the several options to enable the connectivity for InTouch. That'll make the runtime application there and accessible through OPC UA to other clients. All right, moving forward with what's new in 2020 R2, we continue to place a strong focus into the IoT part of our infrastructure. And it's important to note that as part of the edge to enterprise connectivity, what we want to do is we want to provide a very connected story from end to end. So what you can see here on the left is as it relates to IoT and MQTT, we can consider these left things as edge of network devices. And I have a little bit of a diagram here to show you that, but a very, very small sensor can be IoT ready. It can be ready to communicate with MQTT devices. Some of the PLCs in the industry are now starting to communicate via MQTT, but traditionally they don't. And this is where our software offerings play a strong part, both from the Aveva Edge side, becoming an MQTT edge of network node, as well as through our communication driver suite, becoming a publisher and a subscriber, so that we can bring different levels and scales of connectivity to you very seamlessly. So that way we can bring the data in from the edge of network devices, and into our different client applications. So what we have done in the 2020 R2 timeframe is to basically make sure that our applications are Sparkplug compliant. And I will speak in our breakout. I'm actually going to talk a little bit about that later, but during our breakout, I'm going to focus very specifically on what does that mean. For the purpose of now, let's take a look at that example of what does it mean for us to have that edge to enterprise story. So the case may be very different depending on the industry, but for what we want to see here, we want to show something in the field. And more specifically, geographically in distributed applications. Wind turbine examples are great for that purpose. So these assets are going to be bringing the data either through transmitter, PLCs, RTUs, and using our Aveva Edge, we can consolidate the data from those different devices. Remember that Aveva Edge has also a multitude of communication drivers built into it, so it can become really our edge of network node concentrator, right? So what we're doing here is we're actually normalizing the data from all those different edge devices and putting it into Aveva Edge. Then Aveva Edge will leverage MQTT to publish the data to an MQTT broker. What we want to focus on, and what I will be showing later, is what does this MQTT Sparkplug specification do, and how do we leverage to be more, from an efficiency perspective, to bring that information into our application. So now through our communication driver, then we can consume that data coming from the field and bring it into whether it's system platform, InTouch, history, or whatnot. We're showing system platform here for the case. One of the very differentiators here in this diagram is the fact that Aveva Edge can run into a multitude of environments, whether it's Windows or Linux. That's where we can put place our software offerings in systems like that support the Linux environment or the Windows environment, depending on what it is. Now, from a breadth of coverage of the MQTT, we support both the traditional JSON-based MQTT payloads, which is what came originally, and now we support what we call the Sparkplug specification, which is meant to be a normalization for the industrial customers. Right? Not only that, it is important for us as being industrial applications that the connectivity to those IoT devices be very robust. So one of the important parts here, in addition to being very robust, is what we call it as store and forward supporting Aveva Edge, very similar to the functionality that we have with our historian. As an example, and I'll move to my next slide, which will be a little bit more telling. When you start deploying this in high scale into tens, hundreds, or thousands of devices in the field, you want to have a very comprehensive support for your devices. So think about, how do I manage my assets in the field? We leverage our container application for Aveva Edge so that I can centrally manage that application, deploy to my edge devices, and then by the nature of MQTT, we start consuming that data into system platform in a very highly scalable fashion. So that is part of the story of MQTT and the network as it relates to the architecture. Now, what does it mean for us to then start leveraging that information? Remember, yes, this use case can be very common for you, but think about this. It doesn't have to be a wind turbine application. It can be devices within your facility. Within the facility itself, you can be connecting devices internally, different lines, different sites. All these edge devices can be, as I shown in the diagram below, before, considered as edge of network devices. Now, from a topology perspective, we can look at this in these ways. And this is where the standardization of the MQTT comes into play. We have the edge of network devices. Now, some of them can be smart, as I mentioned before, but traditionally, these are either PLCs or devices that we're going to be connecting with our edge applications. In this particular case, Aveva Edge. Aveva Edge will then act as what we call the publisher in the network. So it becomes an edge of network node. Now, what does it publish to? In MQTT, you always have this middleman, the MQTT broker. And it basically helps you divide the information path between the application in the edge and those clients that want to get to that application. So instead of having a one-to-one relationship, you can have one-to-many relationship. So it is extremely, extremely efficient. And again, we'll talk a little bit about that in our breakout session. Past the broker, you're going to have clients up on the top. And in the industrial specification, in the Sparkplug specification, one of the clients is called the SCADA host, the primary application, and is differentiated in its behavior a little bit from the other ones. So again, I'll leave some of those details for I guess I have very, very stiff competition with Eduardo and John and Ernst. So I have to leave some information to see who is actually interested in learning much more about MQTT. And how does what does it mean for us to support the Sparkplug specification? So now, why is it so important, and why is it becoming so prevalent in our industry? Although we support the telemetry protocols, as I mentioned before, for power distribution, such as DMP3 or IEC 63070 for water, wastewater, and whatnot. There are industries today that still leverage those traditional protocols, such as DMP3, IEC 63070. But now with MQTT, we can actually not only target those industry verticals in a much more simpler fashion, but now we're starting to bring in much more connectivity on other industry verticals that we didn't tap on before. Smart city applications, plant globalization, as I mentioned, bringing the data from your different sites into a consolidated area. The usage of unified operations centers with Aveva, tremendously easy to integrate this data from areas that used to be harder in the future. And not only that, but OEMs are becoming a very, very strong part by either managing machines remotely or monitoring maintenance of those equipment that they sell to customers. Okay, a little bit of a smaller piece of functionality that we added here also in 2020 R2, but I think is very functional, especially if you're a system integrator or a plant engineer or even a maintenance engineer in the plant. Diagnostics part of our portfolio is very important for you, especially when it relates to connectivity. Every hiccup in connectivity obviously is going to affect your uptime and productivity. Although our communication drivers has an excellent diagnostic suite, one of the areas that we decided to improve was in those areas of performance and to help you kind of troubleshoot or see how you have optimized your communication. So whether you're looking at making it better or how is it running, this area is a very, very small improvement, but it gives you the visibility of how your system is configured and how you can improve it. So what we have done is in the diagnostics section is to show you the actual package time that a message takes to go between the driver and the PLC. So this is basically bringing or simplifying things that you have used in the past. If you are familiar with Wireshark, basically we are simplifying the data that you have to collect from Wireshark and showing it to you here. So as an example, if we look here at the topic that is normal, the typical update interval is 1,000 milliseconds. The actual time that is consuming for all the messages is 359 milliseconds. And then you can see the number of messages and the time per message. So that this is very key information that somebody that it's either in maintenance, engineering, or support will be able to look at If these times or numbers are exceeding, then it can tell you why the numbers are being higher than the expected throughput rate that you would traditionally see. So very important there from a diagnostics perspective. And for those of you that are also not very aware of the traditional offerings, because the communication drivers are typically bundled either with system platform or with InTouch, I want to let you know you can also purchase them independently or add them to your existing portfolio in different tiers. You can see that we have in what we call a license, which is for very, very small applications up to 32 tags. You can actually do it without a license. But then moving forward for that, you have the standard, professional, and premier, where here we added different levels of functionality. And for, I guess, for time's sake, I'll just highlight over here that, with the professional license, this is where we start adding the multi-instance and the multi-version, as well as auto-build for both the Rockwell controllers as well with Siemens, very, very strong piece of functionality. And then in the Premier license, we add Telemetry Server as well as built-in redundancy there.
Thank you, we actually, we can, sorry to interrupt here, but we do have one more presentation from Brian we need to jump into, and so we can definitely move this into the breakout sessions.
Sure. No, I am actually done here, Mike, with this information, and just let you know that during the breakout session, we're going to be adding or doing a deep dive on Sparkplug. So
great, thank you, Alvaro. Yeah, lots of chat, lots of questions on communications. So great topic, always popular topic. So thanks for the great content and presentation. And